Welcome to day 3 of the AIM program. Today is just going to be about long multiplication. Next, there we go. So from yesterday or previous video, whenever you watched it, just about fractions, so some new vocabulary that we had last time, a numerator, denominator, top and bottom of a fraction. Reciprocal, the sort of flipped over version of a fraction, or more generally we have this word inverse. Both are useful to know, or invert as a verb there. We talked about simplifying or reducing fractions to their simplest possible form. Often we do that by finding a common factor. So some number that can evenly divide both the top and bottom number, excuse me, both the numerator and denominator, those are common factors. When we have that, the same number on the top and bottom will cancel each other out, or we can eliminate them to help simplify our fractions. Also, we talked about finding a lowest common multiple when adding or subtracting fractions. All right. Right. So with all those terms, we simplified, added and subtracted, multiplied and divided fractions, simplified complex fractions, and converted from fractions to decimals. And then in, not today, but in the next day, when we talk about long division, then we'll see the other direction from decimals. Sorry, I think I had that wrong. We did from decimals to fractions, and then we will see going from fractions to decimals when we do the long division practice. Okay. All right, and there were lots of practice exercises. I hope you actually did some of them for whatever parts of this were kind of a little less familiar or less strong for you. Actually doing that practice is a very important part of this. Today, just long multiplication. We don't really need any fancy vocabulary. We'll go through, I have 3 sets of examples and then have some practice questions for you, and then that's it. When you see the practice questions and also the examples that I'll be talking about today, we are actually talking about 2 different textbooks, which we can see here. So the pre-algebra textbook, chapter 1.4, excuse me, and also the intermediate algebra textbook, chapter 1.4. I gave links and information for all of those previously in day 1. But just make sure if you're following along in the textbook with the examples we're doing or doing the practice questions, just please make sure you're looking at the correct textbook. It's a little confusing to have 3 different textbooks we're using, but every slide, every time I give you practice questions, I've very clearly labeled which textbook it's from. So please just pay attention to that. Like right here with our first example, from the pre-algebra textbook, example 1.45. All right, we are just going to multiply these 2 numbers here. So we want to do, right, 286 times 5. So our long multiplication method here, basically what we're doing is we're taking the 286 and saying, well, that's the same as 200 plus 80 plus 6 times 5. And then if we distribute that, then that's 200 times 5 plus 80. That's not it. There we go. 80 times 5 plus 6 times 5. So figure out each of those separately and then add them together, and that will give us our result. So just a nice way of splitting things up. And of course, we write that like this: 286 times 5 So 5 times 6 is 30, 0 down here, and then kind of, let's, different colors. 0, kind of carry the 3 here. 5 times 8 is 40, 40 plus 3 is 43, so 3 goes down here. Second digit comes up here, carry the 4. And then 5 times 2 is 10, plus 4, 14, so 4, and nothing left, so we just write the final digit up there in front. So 5 times 286 is 1,430. And we can see that if we did this 5, yeah, we'll do it this color. So 5 times 200 here would be 1,000, plus 5 times 80 here would give us 400, and 5 times 6 is 30, and then we can very easily see if we added those together, we would get 1,430. Okay, so simple long multiplication example first, and then we'll have some more complicated ones in a bit, the next set. Okay, so that's the detailed explanation, and then let's do, as usual, my turn here. All right, 347 times 5, so that's 35, different color, 35, carry the 3, 23, so 3 here, and 2, and 17. Okay, so 1,735 is our answer here. That was my turn. So now, your turn. Okay, so answer here is, writing tool, 3,234. So hopefully you got that same answer. If you didn't, go back, try it again. If you still have trouble, go back and watch the examples I just did and see the process, and then follow that. Okay. Next one, 2 more sets of examples. I know, these are not like super hard or whatever, and yes, you definitely learned this back in middle school or something, but we're just, if you haven't done math in a while, we are kind of waking up that part of our brains, making sure we're able to do this stuff quickly and accurately in our heads without needing a calculator. Okay, so longer multiplication like this, we still have this sort of split everything up idea. So 354 times 438. Sometimes, they'll tell you write the bigger number on top. It doesn't really matter, especially if they're the same number of digits, so whatever. This will work just fine for us. So okay, let's do the first row here. So 8, so we're doing this. 8 times 354. So 8 times 4, 32, carry the 3. 8 times 5, 40, plus 3, so 3 and 4 here. And then 8 times 3, 24, plus that 4, so 28. Okay, so that's 8 times all of that. And then the next thing that we are going to do, so basically we're doing 354 times 8. And then we are also going to add to that 354 times 30. That's the 3 here. It's actually a 30 because it's in the second digit position. It's in the tens position. Okay, and we know that all these, we'd have a 0 at the beginning of all of this, so we'll just kind of mark that here and then kind of pretend it's not there and just do sort of single digit multiplication there. So 3 times 4, 12, carry the 1, and 3 times 5, 15 plus 1, 16, carry a 1, and that's 9 plus 1, 10. Okay, so that's the next row, and then the final row, same idea, but we have to multiply the 4 times all of this. So that's 354 times, what's our thing here, times 400. Okay, so 2 zeros, so 2 little x's here. And then 4 times 4 is 16, carry the 1, 4 times 5, 20, 1, carry the 2, and 4 times 3, 12, and the 2 there is 14. All right, and then we can add everything up, and that's not all lined up nicely here, but 0 and 5, and that's 20. So, sorry, yes, that's 20. So 0 plus 2 here. So that's 3 plus that 2 gives us 5 and 5. And I don't know why I wrote a 0 in that first position. Sorry, let me correct that. That's a 2. There we go. The rest were zeros. So 155,502 is our final answer here. 155,052. Okay, so as long as we just kind of remember this idea that we are splitting up the operation into multiple parts like this, then like we can, it's not too hard to see kind of why this works and then what our process is here. All right, that's the long example. Got 2 practice ones of this, one for me, one for you. So here's the one for me. 265 times 483. Actually, let's just write that a little larger. Don't need to be so small. 265 times 483 multiplied here. All right, 3 times 5, that's 15, carry a 1. 3 times 6, 18, carry that 1, 19. And add that 1 there, it gives us 19, carry the 1. 3 times 2, that's 6, plus that 1 is 7. Okay, next row. 8 times 5 is going to give us 40, and carry the 4. 8 times 6 is going to give us 48, plus that 4 is 52, so 2, carry the 5. And 8 times 2 is 16, plus that 5 is 21. All right, so I, like any good mathematician, I enjoy being lazy, or as we would say, efficient. So I'm going to notice that this is 8 times these things, and then the next row, the final row, is just 4 times those things. So the result should be exactly half of what we just found. So if 8 times this is 2120, then 4 times that same number should be exactly half. And if we can do that easily in our heads, then that's a nice shortcut. So 2,120, half of that would just be 1,060. So let's just verify here. 4 times 5, that's 20, so 0, carry a 2. And 4 times 6 would be 24 plus the 2, 26, so 6 there, carry a 2, and then 4 times 2 is 8, plus 2, 10, so 10. Yep, works out. We can verify our results there, but again, if we see shortcuts like this, and we are confident we can do them accurately, then no reason to do the long way. Math is all about shortcuts. So 5, 9, 9, 7, 2, and 1. So 127,995 is our result. Okay, that one's for me. And now an example or practice for you. Go ahead. All right, and we're back. I am back. Our solution to this was a larger one. 600, I'm double checking my notes, 653,462 is the answer here. So hopefully you got that same number yourself. Again, if you didn't, go back and try it again. Okay, last set of examples. Double check, yeah. Last set of examples for us to do here is if we have numbers involving decimals, really not hard to deal with at all. So let's do that here. So the process where we will first we will ignore the negative sign in front and we will ignore the decimals. So 4, 0, 7, 5, and 3, 9 here. We can kind of write in the decimals, but while we're doing the multiplication, we're going to sort of pretend those decimals don't exist. And then we will, excuse me. We'll put the decimals back in afterward. All right, so 9 times 5 is 45. So 5 down here. Carry the 4. 9 times 7 gives 63, plus that 4 is 67. Carry the 6. 9 times 0 is just 0, but plus 6. So 6 here, and 9 times 4 is going to give us 36. Okay. All right, so then our next line here. Again, I kind of want to be a little lazy. So we just did 9 times all of this, and the next one will be 3 times all of that. We can just kind of look and see, hey, maybe this isn't too hard to figure out. So 4,000 times 3, 12,000, whatever. But also from here, if we just did 9 and it gave us this, then if we can just mentally divide by 1/3, then we can just skip right to our answer there. So 3 divided by, right color. So 3 divided by 3, that's just 1. 6 divided by 3 will be 2. 6, 2, 75 together, 25. So without doing kind of the 1 by 1, I can sort of notice a few different types of shortcuts I can use. Let's just verify. 3 times 5 would be 15. Carry a 1. So 5, carry a 1. 3 times 7 here, 21, plus that 1, 22. Carry a 2. 3 and 0, 0, but that 2. There, 3 times 4, 12. Okay, so it worked out. We got the right number there. All right, so 5, and that's 12. 2, carry a 1, and that's 9, and 8, and 5, and 1. Okay, so this is not our answer. It's not 158,000. Now we have to put the decimals back in. So up front here we can count. We had 3 decimal places in the second number, 1 decimal place in the first number. So 1, 2, 3, and 1. So let's just put those back in here. 1, 2, 3, 4. There is our decimal. So it's 15.8925. But then also we had that negative sign out front, so let's put that back in. So negative 15.8925 will be our answer here. Okay, so there we go. Just kind of count out however many places your decimal was there and then put that right back in at the very end and you'll have the correct result. All right, let's do another example. I was wondering if I wanted to explain where that comes from. I don't think we need to. It's not too complicated. Okay, so next example. Our practice here. So like usual, one for me, one for you. This one for me. So 6.107 times 4.5. 35. That's going to be a 0. Just carry a 3 there. So 35, 5 times 1, 5, and then that's 30. Excuse me. 4 times 7 there, 28. So I'm going to carry a 2, but just 28. And 4 and 24. And if we add them, 5, 1, 1, 8, 4, 7, 2. And decimal places, we had 3 in the first one and 1 in the second one. So 4 decimal places will put us right here. And our result is negative, so negative 27.4815. There. Finished. All right, so that was my turn. And now one for you. Here. Go ahead. All right, our answer here is negative 87,600. Sorry, not 600, just negative 87,000.6148 is what I got. Hopefully you got the same result. Okay, that was it. Just that. So we did long multiplication, just sort of with a single digit kind of second number that we multiply by, or with multiple digits and both numbers, longer examples. And then if we have decimals, so 3 different situations that we could come up, should not be too hard to deal with any of those. Lots of practice questions for this stuff in our textbook. We have in the pre-algebra textbook, lots of questions with just integers, so whole numbers, no decimals involved. These questions here. And then if you go over to the intermediate algebra textbook, same chapter number 1.4, but different content, different questions. Long multiplication involving decimals are all of these practice questions down here. They do actually both start with question 2, exercise 257. That's not a typo. That just by complete chance it happened to work out like that. Okay, so there's some practice questions. Again, multiplication, not that hard. Long multiplication, you learned this a long time ago, but just be ready to do it quickly, naturally, accurately. Or hopefully we're always accurate, but also just being able to do it quickly. You don't have to kind of puzzle out the process. Be very beneficial for you. All right, so wrapping up. Hard to remember, we just did one thing today, long multiplication. Take some time to do the practice questions. In the next video, the next day, we'll be talking about long division. So kind of the other half of this sort of long multiplication division part here. And hopefully you'll you are looking forward to that. So that's the end of day 3 here. Thank you for watching, and I will see you in the next video in the next day or whenever you watch it.